This FRQ is another matched pair scenario. You have to read the problem carefully, and especially the prompt part, the big text part, and then reading the question gives you another clue. So let me just sort of like summarize. We have seeds. We have one seed. We have a bunch of seeds actually, but they're going to be divided up into pairs, and one seed is going to be treated with additive, and the other one is going to be the control seed, and they're going to be planted together into the same container, of which we have 12. So we have random assignment into the treatment group of additive and control. So this is just from the description here, we know we're dealing with a match pair experiment. Therefore, we're going to be using a match pair T interval or test to be able to find information about the results. So once you have read through that, the text part of the problem, you know that even though they give us information about the two groups, the control group and the treatment group, you have to concentrate only on the differences because it's matched pair. Now you'll notice in previous matched pair problems, they are sneaky and they give you information about the two groups, but you have to realize that the control group and the treatment groups are not independent of each other. The pairs of seeds are planted within the same pot, so those seeds are connected together because they are sharing the same container. So that means they have extraneous information about the control and the treatment groups as separate entities. They're not independent, so therefore the independent groups assumption fails, so you have to solve this as a matched pair experiment. So you got to work with only the differences. If we did this on the calculator, that would be the information that we stored in L3, L2 minus L1. And L3, it's all about L3 in a matched pair experiment. So we're going to construct a confidence interval. Here is the next clue. It's asking about the mean difference, an interval for the mean difference. So that means, again, we know it's matched pair and we only are concerned with the difference here. So let's take a look. So to do an interval of any type, we've got to check conditions first. So we're going to check for independence. All right. Now, I have in my problem, I have the containers with seeds are independent of each other, because I want to address that the containers, because that's what sort of like the pairing is of, but I also want to get the seeds part in there because the seeds themselves are also independent of each other. So I'm trying to sort of globally state it together. So the containers with seeds are independent of each other, okay? Because I want to. Randomization. The seeds were randomly selected and assigned to the containers for this particular problem. So we have random assignment in the containers to the containers of those seeds. 12 containers with seeds is less than 10% of all containers with seeds. And also, if I look at the 24 Roma tomato seeds, that's also less than 10% of all Roma tomato seeds too. But I'm going to base it on what the treatment group here is, and we're working with those seeds that are in the containers. Check. Number 4. The problem states that the graphical displays indicate that the assumptions of normality are not unreasonable. I love the double negative, all right? Not unreasonable. They write that a lot on the AP. Don't ever change double negatives into a positive because that's giving you too much of an acceptance. So write it down exactly how it's written in the problem to get the 4th check. And then since all the conditions are met, we're going to be doing a match pair T interval check. And so far there are 5 checks. I have a 5 out of 5. All right, so now let's move to the mechanics. Now, the mechanics here is going to be a direct copy off of your calculator. I know that you see some work here, but off the calculator, you're going to get a low end check, negative 2.7545, check. The high end check, negative 1.2755, check. The other thing that you need to make sure that you've written down are the degrees of freedom that we have for this particular problem. So it's the number of pairs minus 1. So make sure you have degrees of freedom written down, and that will give you your 3rd check for the mechanics. So 3 over 3 here for the mechanics. Now the last little chunk here is going to be for part A, interpreting the interval. I am 95% confident, check, that the true population mean difference, check, right, has to be in that order, okay? Now the context, copy from the problem, all right? Write it down exactly how it appears in the question. In growth of the of the plants from the untreated and the treated seeds. And I would add in maybe for Roma tomato plants, check. So you got to get context in there. Is between, now the interval needs to be written, check. And that there needs to be units. And we know the units are centimeters because we're working with quantitative data, check. So the interpretation is worth 5 checks, and I have 5 out of 5 here. All right, so that is part A. Part B says, based only on your confidence interval, is there sufficient evidence to conclude that there is a significant mean difference in growth of the plants from untreated seeds and the plants from treated seeds? And says, justify your conclusion. You're not supposed to do a test here, all right? Even though it talks about sufficient evidence, it makes you think test, 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 but it says based on the confidence interval. All right, so that means you don't have to do anything more work-wise. You look at the interval and remember what the magic number is. So your answer for B has to be yes. So there has to be an affirmative. Give yourself a check mark for that. Okay. You need to make sure you have context. There is sufficient evidence to conclude that there is a significant mean difference in the growth of plants from treated and untreated. So there is context. This is the justification. How did you know that it was significant based on the interval? It's because 0 is not in my interval, and that is the third check. So this one, there are 3 checks for part B, 3 out of 3. So overall, this problem is worth 16 points. My person got all 16 out of 16, so write that number at the top of your paper, and you are done grading this particular FRQ.